the Math and Physics Resource Center from Saginaw Valley State University. My name is Amanda, and today we're going to be looking at Math 261 using fundamental theorem of line integrals. In order to do this, we're going to look at the example that's going to verify the fundamental theorem of line integrals. So the fundamental theorem of line integrals states that the integral along some line C is going to be f dr, and then that's going to end up equaling f of r b minus f of r a. So in order to verify this, we're going to solve this example here. So to solve this integral, we're first going to define the integral f of xy into p and q, where p is 2x over y, which would equal, where x is t and y is t cubed, it's going to be 2t over t cubed, which comes out to be 2 over t squared. So now let's do the same for q. We know q equals negative x squared over y squared. So if we plug in the t for x and the t cubed for y, we end up with negative t squared over t to the 6th, which simplifies out to be negative 1 over t to the 4th. Now let's find our new dx, which is going to be the derivative of the x of the RT, the R of t function. So the derivative of t is going to be dt. And we're going to do the same for the y portion. So dy is going to be 3t squared dt. So now we're going to apply the line integral of f dr equaling the line integral of that region C of p dx plus q dy, which will equal that line integral, which the bounds are from 1 to 2t because everything's in terms of t, and it's going to be of 2 over t squared dt, which we'll add them in the end because q dy is also in terms of dt, and that's going to be plus q negative 1 over t to the 4th times dy, which is going to be 3t squared, and they're both in terms of dt, so dt will be for all of it. So now let's solve this integral. So now we need to solve this integral. So in order to solve it, we need to multiply these and keep this one the same. So we have 2t squared plus this multiplied, which is going to give us, not plus, but minus 3 over t squared. So now we can combine these two, so they have the same denominator, and we can make it into a negative 1 over t squared dt. Now if we solve this integral, we're going to have, consider this as negative t to the negative 2, and then you can add 1 and then do 1 divided by the new thing, so negative 2 plus 1. So with that, you're going to get t to the negative first, which is 1 over t, and that's going to be times 1 over negative 2 plus 1, which is negative 1, and that times the already existing negative, so you're going to get positive 1 over t, and that's going to be from 1 to 2. Solving that out, it's going to be 1/2 minus 1 over 1, and that comes out to be negative 1/2. So now let's verify the fundamental theorem of line integrals. So after solving it this way, let's see if the statement f of r of b minus f of r of a equals f of r of 2 minus f of r of 1. So in order to verify the fundamental theorem of line integrals, we need to find f of xy. So we know that big F of xy is the gradient of f of xy. So if we just reverse this, we can find that f of xy is going to be the integral in terms of x of the x portion and that's going to be and the derivative of the y portion in terms of y. So when we take the integral of both of these, they both come out to be x squared over y. So since they're both the same, we're just going to take the x squared over y, and that's going to be our f of xy. So now let's verify this theorem. So to verify this theorem, we're going to plug in f of r2, which we know f of r2 is going to be 2, 2 cubed. So we're going to plug in 2 for x and 2 cubed, which is 8, in for y. And that's going to be minus the same thing, but we're going to use 1 this time. It's going to be 1 squared over 1 cubed, which is 1. So this comes out to be 1/2 minus 1, which comes out to be negative 1/2. So that verifies the previous statement. Thank you for watching this video from the Math and Physics Resource Center from Saginaw Valley State University.